Okay, so here we are for section 4.2, angles of triangles. Um, this is probably the second section and probably the last one for the chapter where you'll maybe know anything about triangles ahead of time. The whole chapter itself, and again, I'll mention this in class, but just to kind of reiterate it, is all about triangles and their applications and all these little special theorems about them. So a lot of this will be, for this section, might seem like review, but a lot of it will also be new, and then like I said, from here on out, it's all new basically. So first of all, we've classified triangles by their sides and angle measures. Now we're going to use the triangle angle sum theorem and then the exterior angle theorem as well. So the first one that you might know is the triangle sum theorem, angle sum theorem, that a triangle, all of its angles add to be 180 degrees. What you might not know is how do you prove that? So it's actually a pretty simple proof. And it goes back to chapter 3, which is why we do chapter 3 before we do chapter 4. So what I can do is draw something that the book mentions is called an auxiliary line. And what an auxiliary line is a line that goes through point B. And actually it's a line that helps us in the proof, but what it's going to do for us is going to go through point B and be parallel to AC. Now maybe saying, why do you do that? Well, let me extend this line here. Okay. I know up here, okay, I know for a fact that this is a line. So this whole angle here is 180 degrees. I also know that angle B, we'll call that angle 1, is there. Now, what I also know is parallel line, transversal, this angle is congruent to this angle. So let's call that angle 2. That's angle 2. And then I also know, again, transversal, parallel line. Oh, here's a pair of alternate interior angles that are congruent. Let's call that angle 3. Well, here's the deal. Angle 1 plus angle 2 plus angle 3, all three of those guys add up to 180 because they make a line. But hey, angle 3 is congruent to that angle 2 is congruent to that angle, so angle 1 plus angle 2 plus angle 3 also has to add up to 180, meaning a triangle adds to 180 degrees. Okay. So that's the formal proof for how to do that. If you look in the book, they walk through it. Now, work here, they just kind of like to throw random problems at us. About all kinds of stuff. So here's one about softball players. So the diagram shows the path of the softball in a drill developed by 4 players. Find the measure of each numbered angle. Okay, so here we go. So the first thing we got to figure out, a lot of times the first thing is angle 1. But also in this one here, the reason this is important that we do angle 1 first is, hopefully looking at the drawing you catch pretty quickly, angle 1 and angle 2 are a pair of vertical angles. So if I can figure out angle 1, I know angle 2. Now, how can I figure out angle 1? Well, this is a triangle. The 43 plus 74 plus 1 has to equal 180 degrees since how many degrees are in one triangle. So add that together, that's 117 plus measure of angle 1 equals 180. Subtract 117. Measure of angle 1 then has to be 63 degrees. So measure of angle 1, 63 degrees. That also means that measure of angle 2 is equal to 63 degrees. Okay. And then doing the same thing we did for this one, I can say, oh, well, angle 2 plus 79, so 63 plus 79, and then plus measure of angle 3 has to be 180. So 63 plus 79 is 142. Subtract off 142. That gives us measure of angle 2 is 38 degrees. Sorry, measure of angle 3. Measure of angle 3, not 2. I kept putting 2 there. Measure of angle 3 is 38 degrees. Okay. All right. Here we go. I'm sorry. Next problems. Exterior angles. Okay. So the exterior angle theorem is what this is for. And how it works is you've got a drawing where you've got your exterior angle, and the definition for that is an angle that forms a linear pair with an internal angle of a triangle. And then your remote interior angles are the interior angles that are not adjacent to an exterior angle of a triangle. So I got a drawing here of the same picture we got. So any triangle, if you extend it aside, we'll call this angle 2, we'll call this angle 3, and then we'll call the inside ones 4, 5, and 6. 4, 5, and 6. Let me look more like a 6. There we go, more like a 6. Angles 1, 2, and 3 are all exterior angles. So angle 1, exterior. Angle 2, exterior. Angle 3, exterior. But for angle 1, okay, angle 1 is adjacent to angle 4. It's too remote interior, and remote just means away, like a TV remote lets you control the TV from away. Angle 1's remote angles were 6 and 5. Angle 2's remote angles, well, 6 is the one it's adjacent to, so they're 4 and 5. And then angle 3's remote interior angles are 4 and 6. So again, remote interior angles are the ones that are not adjacent to the exterior angle, but inside the triangle still. All right. Now, there's a theorem about the exterior angles, about how they work out, and I'm just going to make up some angle measures here real quick. I'm going to say angle 4 is 40, angle 6 is 70, and then that leaves us with angle 5 being 80. I know that's not actually true as far as how this, no, sorry, 70 is. No, let's make this, gosh dang it. How about make this 50, we'll make this guy 60, and we'll make this guy 70. Yeah, because 50, 60, and 70 add to 180. Now, angle 4, if it's 50, that means angle 1 is 130, because they got to make 180 together. If angle 5 is 70, that means angle 3 has to be 110. And then if angle 6 is 60, that means angle 2 has to be 120. Now, here's what happens. So angle 1 is 130. Angle 2 is 120. Angle 3 is 110. If I add 6 and 5 together, 6 is 60, 5 is 70. 60 plus 70 is 130. If I add 4 and 5 together, 50 plus 70 is 120. If I add 4 and 6 together, 50 plus 60 is 110. Notice the exterior angle always adds to its two remote interior. 120, 120, 130, 130. That is the remote interior angles theorem. Or sorry, the exterior angles theorem. It was remote interior in our old book. The exterior angle theorem. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interiors. So angle 1 is equal to angle A plus angle B. Angle A plus angle B. Using this, this is something, or proving it, is using something called a flow proof. And how a flow proof works is you basically use two different lines of thought and they flow together, kind of like, you know, flowing down a river or something. So we know we have a triangle, ABC is where we start off with. Okay, 1 and 2 form a linear pair is the first statement they're going to work out. And then because 1 and 2 are a linear pair, then we know that they add to 180. So 1 plus 2 adds to 180. That's the right side of this proof. Okay. Now the left side says, okay, you're going to get this triangle. Well, if you're a triangle, all the angles, A, B, and angle 2, which is really BCA, those guys have to add to 180 as well. So now we get to the proof part where, hey, look, this guy equals 180. This equals 180. So by substitution, they're going to have to be equal to each other. And then on both sides of the equation, they both have an angle 2. So what happens on the proof is you cross out the angle 2. You just say, nope, no more angle 2. You're gone, angle 2. So what that means is that the angle 1 has to equal A plus B. Well, what's A plus B? 1's the exterior. A plus B are the remote interiors. And you can't really see this with your paper. There we go. A plus B is angle 1. Now, homework or example-wise for this, kind of working this out, it's really just knowing the theorem and setting up an equation. So, you know, they give us a flower garden just to kind of give you some context. Doesn't really matter. The key is that this is the exterior angle. Those are the non-adjacent interiors, the remote interior angles. So by the external angle theorem, exterior angle theorem, this has to equal the sum of those two. So 2x minus 48 has to equal x plus 32. So subtract an x, add 48 to solve. That gives us x equals 80 when I add those together. Now the question is, what's the measure of angle FLW? Oh, well then plug in 80 for 2x. That gives us 160 minus 48, which gives us 112. So there it is, measures 112 degrees. There are two other theorems here at the end of the section, and hopefully they're kind of common sense theorems. The idea is the acute angles of a right triangle are complementary. Well, that should make sense. If a triangle adds to 180, you take away 90 degrees. There's only 90 left for A and B to add together. Okay. And then the next theorem, we'll talk about this in chapter 5, but there can be at most one right or obtuse angle in a triangle. Okay. And we already kind of said that earlier, that every triangle has at least two acute angles. But we'll come back in chapter 5 and talk about why we know this to be a true statement. So hopefully again, kind of common sense. Now for tomorrow, from this drawing here, figure out angles 1, 2, 3, 4, and 5. And that's where we'll start class at tomorrow. So yeah, thank you, and I will, I guess, see you tomorrow then.